Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be revisiting the Microdrone 3.0. As you may know, it's rare that I keep a ready-to-fly micro quadcopter in its stock form. In fact, modifying them is one of the reasons that the channel started. And now that the review of the Microdrone 3 is done, it's time to try and improve on it. I did like the Microdrone 3, as you may have seen in my review, but many people were disappointed with the camera's performance against what was shown in the initial trailer that sold it to them. Before I start any modifying, I want to state that I am doing so at my own risk, and I would not recommend making any of these changes to your own Microdrone. But I'm an idiot, so let's see what is possible. The improvements that I plan to make are as follows: a 120-degree wide-angle lens for a better field of view, a 5.8 GHz FPV transmitter rather than the 2.4 GHz Wi-Fi transmission for better range and video latency, a 720p HD video recorder at 30 frames per second against the maximum stock frames per second of 25. I plan to do all of this retaining the original camera case and also retaining the magnetic snap-on feature of the original. To do this, I will be using the Hubsan H107C 2-megapixel camera, which has a video out feature. I will then use the wide-angle lens off an 808-16 camera. You have to remove the glue off both of the lens housing and unscrew the lenses to swap them over. This is much harder than it sounds, as they are glued in really well. And a quick tip, if you plan on doing something like this yourself, be careful not to get any dust on the sensor when you're swapping them over. I used an air duster to blow any debris away, otherwise you get black spots on your footage. To transmit the video back to the pilot, I will be using a video transmitter from FPV Hobby. These are expensive though, therefore I have also tested this with an FX7582 video transmitter and it works perfect as well. These are only 7 GBP. I like the channel selection button of the FPV Hobby VTX though, so I will be personally using that. For the antenna, I'm using a Hubsan H107D antenna, which I bought as a spare part. This is so that I can clip it into its original casing. In order to ensure that there's no video interference coming from the motors, I will also be using my favourite 5V regulator from FPV Hobby. This is only needed for the video transmitter, as the 2-megapixel camera board is already regulated. And if I attach the camera to the regulator as well as the video transmitter, it will draw too much current from the battery and the video feed will fail. For the rest, I have hacked up my original camera. I have removed the pins from the stock camera so I can retain that snap-on magnetic feature. However, the original camera has a built-in diode protection circuit that allows the camera to be connected in any orientation. I will not be doing that to save on weight, so I have to be very careful not to attach the camera on the quad the wrong way round, otherwise the entire system will burn up. I am going to be connecting all this together like so. The 3 pins are actually non-magnetic, it's the outer casing that is. The pins are then spring-loaded to cope with the battery and camera case meeting in the middle. The back pin of the battery is the positive voltage, the middle is actually a dud, and the front pin is the ground. So I have soldered a wire to the front and back pin, leaving the middle pin with no wire connected to it, and I have hot glued it all in place. Epoxy would do a much better final job, but I don't want to do that at the moment for testing purposes. These 2 wires from the front and back pins are then soldered to the positive and negative input of the 5V regulator. The 2-megapixel camera comes with its positive and negative wires already attached. These will also solder onto the input pins of the regulator so that the camera is only receiving the 3.7 volts or so direct from the battery. Then I'm taking the regulated 5 volts out to the video transmitter, which will power it noise-free. Lastly, the 4th solder pad along on the Hubsan camera board is the video out. I have soldered a 28 gauge wire from it to the video input of the video transmitter. You also need to add an extra ground wire from the camera board to the ground of the VTX so that there is a common ground between the two of them. I then split open the antenna to separate the center signal wire and outer ground casing to solder this to the antenna pad on the VTX. I have hacked 2 holes in the original case, one underneath to allow me to gain access to the micro SD card, and a hole on the side that allows me to access the record button for the camera. Also, to house the wide-angle lens, I took an 8M drill bit to allow the lens to feed through to the sensor. I used hot glue to keep everything in place and electrical tape to hold the VTX to the casing underneath. There was not quite enough space inside for everything, and it's good to have the VTX on the outside of the case to keep it cool as well. The finished unit weighs 15 grams, the Micro Drone 3 will lift this easily, and it doesn't look too dissimilar from the stock unit either. Before I take it for a test flight, we have a few different FPV video receiver options. The easy option for me is to use my Fat Shark Dominator V2 goggles with the built-in DVR. However, if you would like to retain using the phone holder that comes with the micro drone, you can use the Android RX module from Laser BGC in conjunction with a Fat Shark module to FPV via the phone. I have done a separate video on the channel on how to do this if you are interested. I had about a 10-minute window where the skies cleared and we didn't have any rain. It's about a 12-mile-an-hour wind, which isn't ideal at all. But as you can see, the view is pretty impressive. I think that this is an improvement over the micro drone stock footage. We now have a 30 frames per second 720p recording, which is closer to an 808/16 camera quality, but not quite. I still think that for its size, this Hubsan H107C 2-megapixel camera is the best quality that we can get for its weight and size. While recording, there is a slight frame rate drop on the live feed, but there is not any noticeable latency. I am able to thread the needle through these trees no problem. There is almost no jello to be seen on the video footage either. This is in direct sunlight and the parrot props usually struggle for vibration, but it seems that this set is pretty good. One thing that I know about this combination is that the video range is really good, even up to 1 kilometer as shown in my Ski Sky build. However, having this antenna mounted on the side completely blocks the video signal at around 70 feet or so. So, a bit of free R&D for the micro drone guys here. I would recommend that if you bring out a 5.8 module like this, it's best to at least mount the antenna underneath so that the craft does not block itself from the video signal. Of course, my preference would to be use a micro cloverleaf antenna. However, I think that would be difficult with the small space that I have to work with and also retaining that snap-on magnetic feature. The flight time is actually still pretty impressive despite the unit weighing 15 grams. Indoors, I was getting a 6-minute flight time, and outdoors with all the wind gusting, I was still getting above a 5-minute flight. So the micro drone has a lot of potential in my opinion. I worry that making something like this is probably not cost effective for the company, but it is possible to do and I'm really happy with these results. I hope you enjoyed the video and it gave you some ideas for yourself. Thanks so much for watching. Please continue to subscribe. Cheers.